Okay, right. So basically, the reason why it's called Suvat is because you've got 4 formulas that all mention those 5 letters. The first one we had was V equals U plus AT. We also had S equals a UT plus half AT squared. We had V squared equals U squared plus 2AS. And there was one other one. Just can't remember what it is. Can you say that, Cecil? Okay, so as I said, they mention S, which means displacement, U, which means initial velocity, V, which means final velocity, A, which means acceleration, and T, which means time. Okay. Now, these questions just come down to 2 things, which is algebra skills. Each of these questions is basically pretty much the same as any other question. Basically, I give you almost all the letters, and you have to solve an equation to find the other. Okay, so I could give you V, U, and A, and you have to solve an equation to find T. The worst possible one is if maybe I give you S, U, and A, and I ask you to find T, because that's a quadratic, but that's no big deal. You've got 3 ways to solve a quadratic. You've got the formula, you've got factorization, and you've got completing the square. So that's the first thing, is it basically comes down to your algebra skills, in particular your equation solving. But the other reason, which I think was the reason why you find it hard the first time we talked about it, is you've got to make this decision about positive versus negative. And I think we made a big meal over this because it's way simpler than you think. Basically, you've got to draw a diagram. Okay? So if it was something falling into the sea or whatever, then I would call this the middle point. If you're actually above, so let's pretend this is the sea level. If you're actually above, then that is positive displacement. Okay, remember S means displacement. It means how far you are from some center point. If you're actually below, like if I tell you that you're below sea level, for goodness sake, put a negative where S is. Okay, so that's a very simple decision. All you have to do is put a number where S is. You just need to decide if it's positive or negative. If you're physically above the sea level, make it positive. If you're physically below, make it negative. Okay? You also need to decide which is your positive direction. Now, given that I'm saying that this is positive and this is negative, I think that it would be crazy town if we didn't say that that was the positive direction. In other words, it's just like a number line. So that's 1 meter above sea level, 2 meters above sea level, 3 meters above sea level. And this is the negative direction, in other words, where the numbers are going down. Okay? So this makes it very easy to decide if a V that you put there or there should be positive or negative. Basically, if it's going up, then put a positive number where V is. If it's going down, put a negative number where V is. It's that simple. If you don't know whether it's going up or down, then you're in a tight spot. You can't actually answer the question, unless there's some other clue that you're not appreciating the significance of. Now, the final one, so that's basically V and U that I've just discussed there. In other words, initial velocity and final velocity. The one that's trickiest to understand is acceleration. There's 2 possibilities for a positive acceleration. If you are going in the positive direction but you're slowing down, so like this, then make A negative. So one option is positive direction but slowing down, like actually slowing down, like I just did there. You know, fast and then suddenly slow. But there's another way to get a negative acceleration, and that is to be getting faster in this direction. So for example this. That situation there, that would also have a negative acceleration. So in other words, negative direction and getting physically faster. Okay, now this is a bit of a head stretch for you because I'm sure you always thought of acceleration as getting faster. That's no longer the case. There's now 2 possibilities. If you are slowing down in the positive direction or you're speeding up in the negative direction, when you need to put a number where A is, put a negative number. Okay? So that's all there is to it. Okay? Now, I'll just leave those formulas there best I can. Okay? So here's a just a quick little situation. Okay? So we'll do it with the sea level again. So this is the sea level. Now, I've got a particle. It's currently 5 above. It's been going for 3 seconds since the start, and initially it was resting, and its acceleration so it's getting faster by 2 meters per second per second. That's all you need. Okay, I've given you a time figure. I've given you a what else have I given you? I've given you a acceleration figure. What else did I give you? I gave you a U figure. So I told you initially it was resting, so the initial velocity is 0. Which one can you use? I've given you T, U, and A. Which one? I think there's more than one possibility, but that one's pretty good. Oh, I haven't actually asked you a question yet. So let's say I don't tell you this. So when I ask you how fast you're going now, I'm basically asking for a velocity. So the top equation is the business. Okay? So, I don't know my v. What's my initial velocity? It's 0. What's my acceleration? It's 2, but should I make it negative? Yeah. I don't think I should. I'm going up and I'm getting faster. So it should be a positive. Okay? And I told you how long it had been since I started. There you go. Done. Do another example. So this time we'll make it left versus right. So we'll make this the positive direction. And let's say I tell you that initially you're going that way at 2 meters per second, and then finally you're going that way at 5 meters per second, and where you were and where you are is separated by so let's say initially you're at -2, and then you're at 5. Which ones have I given you the details for? I gave you an initial velocity, so that's U that I've covered. I've given you a final velocities, that's V covered. I also told you displacement. Look, it's gone from there to there. So that's your displacement. So what am I good to ask you? I think I'm good to ask you that one, aren't I? So let's substitute into that. What's my V? 5. What's my U? -2. Is everyone clear on why it's negative? It's because I was going that way, whereas this is the positive direction. I don't know A. And what's my displacement? Okay, well there's 2 possibilities for this. If you regard this as the starting point, as the reference point, then this displacement is 5. Because displacement is not like distance. Distance is how far you've actually travelled, how much, feet you put on the ground. Displacement isn't that. Displacement is how far you are from the start. So, if that is the start, then our displacement is 5. If that's the start, then our displacement is 7. Now you solve those 2 equations and you get your acceleration. Okay? It's that simple. Now somebody must surely want to ask me about this business about the displacement. How it can either be 5 or 7? Somebody must be confused about that, Prashela?
If you're getting two answers, which one do you use it?
Well, I'm just making the questions up to show you how it basically becomes easy once you've got the numbers. This is not a very well constructed question. Okay? In the actual ones that come from the book, they'll always make it crystal clear what you're supposed to be doing. Okay? Does that make sense? But if you were using these in a real situation, and in fact, I mean, no joke, I actually used that in my theory tests for my driving, because they said, if you double your speed, what happens to your stopping distance? Does it double as well? In other words, is that one of the things where if you double this, you double that? What's your gut feeling? You've seen plenty of advertisements. If a driver goes twice as fast, does it take him twice as long to stop? Well, no, it doesn't. It takes him 4 times as long. That's why you have those ads saying it's 30 for a reason. Because you think that you can slow down fast, but you can't. It takes a long time for a car to slow down. That's why the speed limit is 30, because they've found that if the average time it takes a driver to notice a kid, if they're driving at 30, they get slow just in time to only injure the kid rather than kill them. Whereas if they are driving even 40 miles an hour, just 10 above, by the time they get to the kid, they'll be going sufficiently fast to kill them. Anyway, so what I was saying is, if you were actually using this, just set it up, make up your own question, right? So decide which of them is a more realistic situation for you. If this was your starting point, then do that. If that was your starting point, do that. Okay? I'll just do one final little question. Leave the formulas there. So, so I moved 5 meters in the positive direction. I took 3 seconds. At the end, I was going at 3 meters per second. How fast was I going at the start? Okay, so what have I given you? I've given you a displacement. I've given you a time. I've given you a final velocity. So you can guess what I'm now about to ask you. Which formula am I going to get you to use? It's that one, isn't it? You've got all the information you need. You move 5 meters in the positive direction, so your displacement is 5. I told you how fast I was going at the end, it's 3. It must be 3 because it says I'm going in the positive direction. I don't know the u, and I told you that I took 3 seconds. Oh, wait on, 3 seconds. You solve that and you're sweet. So it's 10 equals u plus 3, 3. 10 over 3 equals u plus 3. 3 and a third equals u plus 3. So u equals a third. Now, does anyone want to ask any questions about that?